Good morning, everyone. Welcome back. Thank you for joining us. We're glad that you're here. I'm Steve,
And I'm Scott.
and together we're Backyard Musings. And just in case you're new to the channel, we publish twice a day, 7 a.m., 1 p.m. Pacific time, Monday through Saturday. We take Sunday off.
Yep. And we appreciate anybody that's subscribing or listening and viewing. But yeah, if you can, hit that subscribe button and helps us out. So here we go. And we're talking today about a space topic.
Pretty interesting, too. We were just talking
Yeah.
off camera.
Spacecraft topic. But yeah, it's kind of cool.
A satellite no bigger than a small carry-on suitcase could help investigate a period of cosmic history that has never been directly observed, the moon's far side. Developed in the United Kingdom, CosmoCube is designed to search for evidence of what happened during roughly 150 million years of cosmic dark ages before the universe's first stars began to shine. Would you like to know more?
Led by the University of Cambridge, an international group of scientists plans to send CosmoCube around the moon and use its far side as a natural shield from radio interference generated on the Earth. From there, the satellites will listen for an exceptionally faint signal left by the early universe.
Known as the 21 centimeter line, the signal comes from hydrogen atoms during the period between the afterglow of the Big Bang and cosmic dawn. I've never heard of the cosmic dawn. When nuclear fusion ignited the first stars. Astronomers have yet to observe this era directly.
Searching for a signal more than 13.5 billion years from old from Earth is extremely difficult. The ionosphere blocks the relevant radio frequencies, while FM radio, satellites, and telecommunications create additional interference that can overwhelm the faint cosmic signal.
The moon offers a way around both problems. During each 2-hour orbit, CosmoCube would spend about 40 minutes behind the moon, protected from radio noise coming from Earth. Over a planned 2-year mission, researchers expect the satellite to accumulate around 1,000 hours of observations from one of the least explored periods in cosmic history, providing clues to how the universe evolved from a dark, relatively empty state into the complex cosmos seen today.
The mission has received funding from the UK Space Agency, and researchers hope to launch CosmoCube within 5 years. Details of the project were published in Nature Astronomy on August 14th of this year. CosmoCube is also intended to investigate dark matter, the invisible matter whose gravity plays a major role in forming and holding galaxies together, by examining conditions before the first stars appeared.
Quote, this emission from hydrogen after the Big Bang, but before the first stars, will hopefully allow us to understand the role of dark matter in the early universe, how it worked to pull together hydrogen into the first stars and galaxies, said lead author Professor Eloy de Lara Acedo from Cambridge's Cavendish Laboratory.
The satellite will observe extremely low radio frequencies between 10 and 50 megahertz, a range that is largely inaccessible to ground-based telescopes. That limitation is what makes the moon's far side so valuable as CosmoCube's fortress of solitude.
You gotta love the Superman analogy. Quote, there's no other place where you can get the sort of shielding you need to detect such faint signal, while at the same time looking at the whole of space, said de Lara Acedo, who is also affiliated with the Kavli Institute for Cosmology. Is that like
Makeup?
Makeup? Is that makeup?
Hair and makeup? I think that's cosmetology, isn't it? Cosmetology.
Cosmetology, yeah. Cometology?
Cosmology? Would that be the study of the cosmos? I don't know.
You're enfeebling my brain, Scott. Stop it.
Sorry.
Quote, continuing his quote, the far side of the moon is really the only option. It solves multiple problems at once, opening a clear window to the very early universe.
Once CosmoCube reaches lunar orbit, it will deploy a long, lightweight radio antenna designed to detect the 21 centimeter hydrogen signal while the spacecraft passes behind the moon.
Because the desired signal is so weak, CosmoCube must also carefully track noise produced by its own electronics. A Dike switch, DICKE switch, calibrator will repeatedly alternate between observations of the sky and several built-in reference sources, allowing researchers to identify and correct small instrumental drifts that might otherwise imitate a cosmic signal.
After the observations return to Earth, researchers will apply advanced Bayesian, Bayesian, Bay, Bayesian,
Bayesian.
Bayesian,
Yeah.
Bayesian. Okay. Statistical techniques to separate the desired signal from foreground emission, particularly radio waves produced within the Milky Way. Computer simulations and in-flight measurements will also be used to reconstruct how the antenna responds to different areas of the sky so that remaining distortions can be removed.
Quote, aside from the science, what makes our mission unique is its size. We're probing the earliest, deepest parts of dark ages that others don't reach, but with a compact, relatively low-cost platform, said Delera Aceto.
The radio quiet environment on the moon's far side may eventually become harder to preserve. The US, India, and other countries are planning missions that also hope to take advantage of its unusually quiet conditions.
CosmoCube will carry a fully integrated miniature radiometer combining modern analog and digital technology through RF systems on chip, RFSOCS. Its spacecraft platform called SSTL-21, probably the 21 is 21 centimeters, is being developed in the UK by Surrey Space Technology Limited, which specializes in manufacturing small satellites. Working lab prototypes already exist. Environmental testing is underway, and the project includes collaborations with industry partners. UK academic partners include Portsmouth. Oh, this looks like a resume here. Include Portsmouth University and STFC RAL Space, with participation from EU countries including Malta.
Wow.
Okay. The CosmoCube team also recently took part in the ESA Mini East mission's call for ideas, targeting a mission costing less than 50 million euros.
Yeah, you don't. I mean, Malta is not definitely on my list for somebody you're
No.
collaborating, right? That's
For space stuff, no.
Yeah.
Maybe they're providing the money.
Yeah. Quote, CosmoCube is aiming to do some ambitious science from a very small satellite in a challenging environment. And to do that requires some clever design techniques. And that's according to co-author Dr. Will Granger from the STFC RAL Space. Going on with the quote, we've worked with project partners to develop representative models of the satellite and its payload. These have been tested in our facilities to ensure the thermal performance allows the payload to operate and perform the required sensitive measurements under the different temperature conditions it will experience while in orbit around the moon. In the future, we hope to further develop the full payload in preparation for a full mission, unquote. Okay.
Pretty cool.
Yeah. I mean, I wonder if these things will be so small you wouldn't even be able to detect them, right? I mean, you can see a satellite, if it's clear night, you're laying on your back outside looking up at the sky.
Blinking and going really fast.
Yeah. Yeah. If you know where to look, but this thing's going to be so tiny.
Yeah. I wonder if when we get to Mars and we're, flying back and forth to Mars, if we put one of these up behind, there's 2 moons for Mars, put one of them up behind each moon and start studying stuff, like we're doing it here.
Yeah. I don't know. You don't think about the dark side of the moon that often, but
it was a song, right?
Yeah. Pink Floyd. But we have not been to the dark side of the moon. I don't think anybody's been there yet.
China has.
Yeah.
We Chang'e missions.
Yeah. Sorry.
Hey.
Don't buy it. Sorry. But
it was all filmed on a stage.
Maybe in a warehouse in Van Nuys, but yeah. Or Beijing. I don't know. Anyway, thanks for listening. Catch you this afternoon.
Thanks, true believers. We'll see you in the afternoon.
Take care.